Melbourne Central is a 12-storey office building design which was going to change mass timber in Australia. Now, it towered over 300 Lonsdale Street, was super exciting, got me excited, the whole industry excited. The only problem is, it didn't go ahead. It sat in compliance limbo for over a year, costing the developer millions of dollars, just sitting there getting redesigned, and uncertainty. It almost derailed the whole entire mass timber industry in Australia. So understanding fire and compliance is critical for all parties in a project team. So in this video, I'm going to cover the 5 key competencies for structural fire design. So let's kick it off. Number 1, understanding the compliance pathways. So there are 2 compliance pathways in the NCC. You got the DTS solution, the deemed to satisfy solution. Now this is a little bit like a cookbook. So let's say we go out there, we get Marley Spoon or HelloFresh, we got all our food delivered and some other chef has actually put it into menus and recipes that we can just follow. We end up with a pretty delicious meal and we're not the expert. Now, secondly, you've got the performance solution. So in our cooking analogy, this is where you actually hire the chef to come to your house and cook the food and make the meal. So it's a little bit the same when it comes to building design. DTS solution, you've got all of the experts putting it into predetermined solutions that you can use. And then you've got the performance solutions, which relies a lot more on expert judgment. So when it comes to mass timber, there is a DTS solution there and it's different for different products. So for example, GLT, there is a manufacturing standard in Australia and you can use AS 1720 Part 4 to perform your design. When it comes to CLT, there isn't a manufacturing standard in the country. Therefore, you have to rely on fire tests. And remember, fire tests, they can be expensive at times. So you got to understand your compliance pathway and know where fire tests are required and where we can actually not need them to perform our design. Now, some suppliers, they do have fire tests where you can have a DTS solution where you can look up span tables and fire design guides and get a simply supported case or a 2-span equal, but it's not going to apply 100% of the cases. And there are cases where a structural engineer needs to go out and perform the design themselves and work out the section modulus and do the design. So it can't be a black box, which leads us to number 2, and that's choosing the right char models. So as timber reaches a temperature that causes the combustion reaction, we begin to lose a little bit of its strength. So traditionally on some products, we can use a single char rate and it's quite predictable at what it burns at. You can times it by the FRL and work out where your post-fire section modulus is. Now for CLT, it really isn't that easy. It's dependent on a few things, including the thickness of the outside lamella, the encapsulation period, if it is chosen, how many layers of encapsulation, is it plasterboard, or is it a new and innovative product? And then you got the glue line integrity. Now, if the char fall off occurs before the fire actually approaches where the glue line is, that means you've actually got a faster char model that might be required. And there are different models around the world, and perhaps Eurocode 5 with the upcoming models coming in 2025 as well being the most appropriate. In addition to that, you got a 0 strength layer which needs to be applied. So this is a heat affected portion of the timber that needs to be removed for your design. And this is different in AS 1720 Part 4, which is local codes, compared to say Eurocode 5. And when it comes to fire design, it's pretty much across the board. When you do crude assumptions for uncertainty, pretty much always it's not on the conservative side. So we actually need to go out there and learn it and apply the correct method so we're always designing safely. Which brings us to number 3, and that's choosing the correct analytical model. So there's different methods of designing CLT in different parts of the world. Firstly, you got the shear analogy method. So this method assumes a perfect connection between the CLT layers. So you can use that to create your effective stiffness and use it to calculate your section modulus and so forth. But according to FP Innovations Handbook 2019, it's not really recommended when layers are unsymmetrical, and that is the case when it comes to fire design. So this perfect connection may not apply and isn't on the conservative side, which brings us to the gamma method. So the gamma method is allowed for non-symmetrical sections. However, it's not allowed when you have 3 or more longitudinal layers, as is the case with 7-layer traditional CLT. So it can be used a lot of the time, but not all of the time. Which brings us to another method called the extended gamma method. So this can be used for all cases of CLT, whether it be unsymmetrical, whether it be 7-layer CLT, 9-layer CLT, CLT band beams and so forth. The only issue with this one is it's quite cumbersome to calculate and requires complex matrices to solve in order to design for CLT in this method. Nevertheless, we need to know when to use each method in the right case. The fourth key competency for structural fire design is matching designs to what has already been tested. So this goes for a lot of cases. Think about your penetrations. In this case, you can match what your penetrations are to what has already been tested by suppliers. When it comes to connections, again, speak to the supply chain, what has been fire tested and is quite simple in compliance, so you don't have to test again. And when it comes to element design, make sure it's been tested. So again, no more expensive, risky fire tests that are unnecessary, then just add huge costs to your project. And in addition to cost, program risk, because it is the fire test sometimes that can hold up an entire project and add a lot of cost. And number 5 is quite simply understanding the engineer's limitations. So as we said, there's 2 compliance pathways. You got the deemed to satisfy solution, then you got the performance-based solution. There are going to be cases where you need to do a performance-based solution, and here we are relying on expert judgment. And this means the engineer, you have to be an expert. You need to go out there, self-learn, and make sure you are performing the correct design. And understand that it's always a team sport, because when it's a structural engineer, you're designing for structural adequacy, but there's also insulation and integrity. Maybe the joints govern what the design is. So some of these things are outside the remit of the structural engineer, and you need to collaborate with the whole team to get the right solution.